Let's talk about finding domains. For problems where the domain, remember the domain is the list of possible inputs for a function, is not listed explicitly, the domain is assumed to be the possible inputs. Okay? So here, what's a possible input? Could I input f of 0? And the answer is absolutely. F of 0 would be 1 divided by the quantity 0 minus 2, or negative 1/2. But by trying to do all of the inputs one by one, you're going to go forever. So let's ask, well, where would a problem be? What would be an impossible input? Well, in a fraction, the only thing that would be impossible typically is dividing by 0. So what we need is we need x minus 2 to not be equal to 0. That means x needs to not be equal to 2, right? Adding 2 to both sides. So if my domain is to avoid being negative, avoid being 2, that means it could be negative infinity up to 2 or 2 up to infinity. So that would be an interval notation, the domain. Another example here is h of x equals the square root of x minus 3. These are sort of the big two examples. Well, notice to get out a real number, this piece inside a square root has to be greater than or equal to 0. You can take the square root of 0. Remember, the square root of 0 is 0 because 0 squared is 0. So this is greater than or equal to 0. That means x is greater than or equal to 3. Okay? Since I can be equal to 3, I'll put a 3 up to infinity. Remember, this parentheses means up to 2 but not including 2. And of course I'm going up to infinity, but it wouldn't make sense to include infinity. So this is including 3, not including infinity. We always go left to right increasing when we write our domains. Okay, so let's put it together, have a little more challenging example here. F of t, oops, and these should be t's. Generally your input there is used over there. Okay, so f of t is the quantity square root of t minus 2 divided by the quantity 2t minus 3. So first off, I see that I have a fraction, so I want to make sure 2t minus 3 in the denominator is not equal to 0. That means 2t had better not equal 3, adding 3 to the other side, or t better not equal 3/2. Okay? Second, I better not have a negative in the square root, so t minus 2 had better be greater than or equal to 0. That means t had better be greater than or equal to 2. So if you drew these two things on the number line, think about what's happening here. This simply says you can have anything if there's negative 1, 0, 1, 2. That means you better not be at this point 1.5 or 3/2. If you were drawing this, it would actually be that interval with an open circle there indicating it can't be that point. But this is much more restrictive. Okay? So this says it better be just strictly greater than 2. So the answer to this, the domain, is 2 to infinity. This piece might play a role or might not. Notice that if this piece was something like t not equal to 5, you'd go, say, t up to 5, and then 5 up to infinity. If this forces you to ignore the point 5. Now that's not our case, so I'll erase that so we end with our case. I just want you to know there are different cases there. Finally, find the domain of h of x equals 3x squared plus 2x minus 1. Now think about this. The question is, what can't I put in for x? Can I put in 0 for x? Sure. Can I put in a positive number? Sure. Can I put in a negative number? Sure. So the answer here is all real numbers, or in interval notation, negative infinity to infinity. Don't get sucked into thinking that something has to be left out. It is all possible inputs, which here is everything.